One and all.
Sir, start.
Good afternoon, one and all. Welcome to the family of TREIS, Telangana State Residential Educational Institutions. So, myself, Ramesh Nukala, I am lecturer in chemistry, TSRJC, Sarvail. Okay, I am very happy to announce that. So, I am very happy to deal one of the topic in the second year chemistry. So I choose the electrochemistry. So today we will discuss about the electrochemistry chapter. Yeah. See this electrochemistry. Yeah. So what is electrochemistry? So before discussion about the electrochemistry, we want some examples. So some daily whatever the uses of the electrochemistry. So daily observation we used in the daily life. So we should know about that one. So whatever the batteries, okay, we are using today's very well. What is that one? Mobiles. So that mobile batteries in that mobile. So batteries are there. That batteries is made up of. So that means the batteries are works with the help of the electrochemistry is the phenomena involved in the work based on the electrochemistry principle as well as these batteries whatever these batteries so in whatever the we are using TV so all that so in what clock all these are some batteries are there this type of batteries so these are used in the especially so in mobiles so as well as we are using tabs so and as well as these laptops all these are so this type of batteries are works with the based on the electrochemistry principle okay so many subtopics are there in that so this one two are the applications as well as this one so actually now every day in our houses in our homes so what is that one in our homes so bulbs are there okay so yeah, so those bulbs are so actually the current will be passed based on the one anode, oh sorry, one anode and another is cathode. So by connecting these two, what will be happen? The current supply will be happen. Then automatically bulb, okay. So power on, power off, bulb will be happen. So these are the some of the daily life uses of the electrochemistry, right? So now we will discuss about the electrochemistry. Yeah. So what are the applications we have seen? Two, three applications. Now, what is the electrochemistry? What is the definition, actual definition of the electrochemistry? Now we will see. What is the actual definition of the electrochemistry? So the interconversion between the electrical energy here, see here, electrical energy to chemical energy, production of the electricity from the chemical reactions, okay, that one conversion and by using the electricity chemical reactions also takes place that means interconversion between the electrical energy to chemical energy and chemical energy to electrical energy these two processes are called as a electrochemistry okay yeah so this is the electrochemistry these two pictures you have to see here these are the belongs to the some of the applications of the electrochemistry this see this one bioelectroconversion so bioelectroconversion means from the bio sources we have to conversion into electrical energy then it is converted into fuel energy that means in this process some of the electrochemistry is involving okay some biological process to what we are using here fuel so in this some electrolytic process electrochemical process that means simply electrochemistry is involving here also some of the applications of the electrochemistry that means preparation of the sodium hydroxide like that so this is also this picture also indicates the electrochemistry yeah see this one these batteries we have discussed these batteries next this one so here also one of the application of the what is that one electrochemistry and see this one what we are saying in the definition electrochemistry is the interconversion between the electrical to chemical energy and chemical to electrical energy first we will discuss first types of what is that one chemical energy is converting into electrical energy okay so chemical energy means this one so here biofuel to that means here fuel is converting so that is called as conversion of the chemical energy to electrical energy this is also this cell also indicates the conversion of the chemical energy to electrical energy here also these batteries whatever this one as well as this battery these are indicates also conversion of the chemical energy to electrical energy so the two types of cells are there in the electrochemistry first one is electrochemical cell so in this what is happening the conversion of the chemical energy to electrical energy. Okay, this one. Yeah. So chemical energy to electrical energy taking place. And the second type of is there, that is conversion of the, sorry, 1 minute. Oh. Madam, please give me host. Here, yeah. Second type of cell, what is that one? Electrolytic cell. In this cell, what is process is occurring? The conversion of the electrical energy to chemical energy. Okay, yeah. So what is happening in this? We are using the electrical energy to chemical energy. We are using the electrical energy and converting into electrical energy into chemical energy by supplying the energy. Here battery, we are using the battery. By using this battery, what is happening? Some electrodes are present here. These, whatever these color, pink colors are, indicates these two are the electrodes. Okay, this one is left side, one is anode, and right side one is cathode. Okay, these two are the electrodes present in the, this is electrolytic. Okay, this is one of the cell. Okay, yeah. So in this conversion of the electrical into chemical energy, we are using the some electrical energy to convert the chemical energy. So this is second type of the uh, cell. So actually, yeah. See this one. So second type of cell is called as electrolytic cell. In this, conversion of the electrical energy to chemical energy taking place by supplying the electrical energy. What is converting here? So by supplying the electrical energy, it is converting into electrical energy. Yeah. See this. Yeah. Next, this one, a voltaic cell. Actually, we are discussing that in electrochemistry, cells are two types. So, what is the electrochemistry? Conversion, interconversion between the electrical energy to chemical energy and chemical energy to electrical energy. So, first types of cell is electrochemical cell. So, in the electrochemical cell also called as voltaic cell. Okay, voltaic cell or galvanic cell. So, voltaic cell is nothing but electrochemical cell. In this, in this, 1 minute. మేడం రావట్లేదా స్లైడ్స్? షేర్ రావట్లేదా మేడం? అయ్యో! ఓకే మేడం. ఓకే. Okay. Yeah, see this one. So it is a voltaic cell. In this, what is happening? Conversion of the chemical energy to electrical energy. While so in the electrolytic cell, what is happening? The conversion of the chemical energy to electrical energy. So ECE. So sorry, ECE. In this, what is happening? Conversion of the electrical energy to chemical energy in the electrolytic cell. Whereas in the voltaic cell, what is happening? Chemical energy is converting into electrical energy. So see this one. So this is a voltaic cell. So in this, what is happening? Chemical energy, by using the chemical energy, electrical energy is converting. But in this case, what is happening? Electrolytic cell. So in this electrolytic cell, completely vice versa to voltaic cell. So what is happening in the electrolytic cell? Conversion of the electrical energy to chemical energy. That means in this, electricity is producing. So in this voltaic cell, electricity is producing. That's why here on bulb is on. So in this cell, electrolytic cell is what is happening? So the electricity is consuming. That is the difference between the electrical energy as well as chemical electrolytic cell as well as electrochemical cell. Electrochemical cell is nothing but voltaic cell. Okay, this one is electrolytic cell. Here in electrolytic cell, electricity is consuming, whereas in the case of voltaic cell, electricity is producing by the chemical reactions, whatever the we are see here in this. So in this, electricity is producing by using the chemical reactions. This one also, this one, in these two, by using some chemical reactions, what is happening? Some electricity is producing in this case as well as in these two cases. Whereas in this case, what is happening? By using the electricity, some chemical reactions are happening. Okay, so that's why it is comes under the electrolytic cell. Okay, right. So previous, these two are the electrochemical cells. Okay, so this is the definition actually for the electrochemistry: interconversion between the electrical energy to chemical energy and chemical energy to electrical energy. So these two. Yeah, see here. Yeah, so what is the scope of this subject? What is the scope of the electrochemistry subject? See here. Yeah, so what is the uses? What is the scope of the electrochemistry? Is first one, large number of metals like sodium, potassium can be synthesized, can be prepared by using the electrochemistry. Electrolytic cells are there. Electrolysis, one of the process is there. By using that process, we can synthesize the metals, sodium, potassium, like that. And also we can prepare the sodium hydroxide, chlorine, fluorine. All these chemicals can be produced by the electrochemistry. Whatever we have discussed, electrolytic cell, electrochemical cell. So by using that one, we can prepare the we can synthesize or prepare these one. Okay, what are those one? Sodium hydroxide, metals, sodium, as well as chlorine, fluorine. All these can be prepared by using the electrochemistry. And second one, we can prepare the batteries as well as fuels. So no, not prepare. So batteries as well as fuel cells will be used. So it is one of the application of the electrochemistry. What will be happening in this? Conversion of the chemical energy to electrical energy taking place. Yeah, and third one, what is the another? So merit or application of the electrochemistry is in these reactions. So conversion of the electric. So the reactions carried out electrochemically. So energy, yeah. So see here, electrochemically can be energy is efficient and less pollutant. Okay, yeah. See this one. So this is a synthetic method to prepare any organic reaction or inorganic reaction. Any reactions, one chemical reactions taking place here. So this is one of the synthetic way. So generally by using the what is the merit of the, or what is the better use of the electrochemistry? By using the electrochemistry, here less pollution taking place and less energy efficient method is electrochemistry method. By but a normal method, in general method, synthetic method is, this is one of the reaction actually we are using. So this is one of the setup for the reaction. So in this one reaction is carrying out. So in this reaction what is happening, we are using, this is a stirrer. So by using the stirrer we are using high temperature, 200 300 150 degrees centigrade, that means high temperature we are using here. Okay, yeah, some solvents are using in this reaction. Okay, acetonitrile, toluene, benzene, some solvents are using in this reaction. So all these solvents, and by using in this reaction catalyst, okay, catalyst, some ligands are using. So all these are what is happening, some ligands, some additives are using in this chemical reactions. Though all these are environmentally, whatever the solvents, organic solvents we are using, those all are the environmentally pollutant. So whatever in this electrochemistry we are using here, so these are, there was very less byproducts are forming. If any byproducts is forming, so that is also we will use. So electrolysis of sodium chloride, what will be used? Electrolysis of sodium chloride along with the sodium hydroxide, what will be happen? Hydrogen gas as well as chlorine gas will be evolved. That is also used. Yeah. So that's why what is happening in this reaction, some byproducts are forming. We are using the organic solvent. We are using the high temperature. So these all are the environmentally not eco-friendly. But so these are whatever the electrochemistry is eco-friendly, less pollutant are coming. That's why so less energy is required in the case of electrochemistry. But synthetic way we are using more energy here, 200 300 degrees centigrades, and we are using the organic solvents. So that's why it is not environmentally benign. Okay, so electrochemistry is the less pollutant and environmentally benign. That's why best way to carried out the electrochemical reactions as well as electrolytic reactions is electrochemistry. Yeah. So what are the objectives of the electrochemistry? See here, what are the objectives? Various types of cells. Yeah. See here, slide show. Okay, slide show. What are the objectives of the electrochemistry? Various types of cells are there. First one, types of cell. So we are discussing that types, two different types of cell. We will discuss again in detail about the types of cell. And second one, cell EMF, electromagnetic force. So cell, what is the cell EMF? We will discuss. Along with the cell EMF, what is the nearest equation? We will discuss in this one. And third one, what is the relationship between the standard potential of cell? Okay, so E naught cell, what is standard EMF cell? And Gibbs energy, delta G naught, delta G Gibbs energy, and as well as equilibrium constant K. Also, we will discuss what is the interrelation between these three. We will discuss in this topic. Next, we will discuss about the what is the conductance and resistance, molar conductance lambda m, and as well as equivalent conductance. All these we will discuss in this one, and as well as we will discuss the Kohlrausch law. Okay, Kohlrausch law also we will discuss and its applications. Last one we will discuss about the Faraday's law. So all these are comes under the electrochemistry chapter. So first one we will discuss about this one. What is that one? Yeah, so this one, various types of cells. Yeah, see this one. Yeah. So types of cell, two types of cells are there. So first one is voltaic cell. Yeah, this one, voltaic cell also called as galvanic cell. Okay, see this one. So this is a voltaic cell. So this will, in this what is happening? Conversion of the chemical energy to electrical energy. We are using here zinc, and here copper. So by using two different electrodes, what is happening? So here chemical energy is copper sulfate, we are using copper. Here zinc sulfate, we are using zinc. So by using these two, what is happening? Some chemical reaction is happening to produce the electricity. Here bulb is. So this is one type of cell that is called as voltaic cell or galvanic cell. And this one, second one, here electrolytic cell, we have discussed that. What is happening here? The conversion of the electrical energy to chemical energy. This picture indicates that one. So here by using the electricity, so chemical reactions is taking place. Yeah, next one. So electrochemical cell. So we are discussing about the two cells. First one is electrochemical cell. What is electrochemical cell? The spontaneous chemical process, the conversion of the chemical reaction to electrical process. So this one is a spontaneous reaction. Okay. Yeah. So spontaneously taking place. So the reverse is called as, what is that one? Conversion of the electrical to chemical is, that is non-spontaneous process. So some terms are there in the electrochemical process. What are the terms we will see here? So actually this is a picture. So in this, some terms are in electrochemistry, some terms, whatever the electrolytic cell or electrochemical cell, some common processes are there. So what are the process we will see here? See here, electrodes, electrolyte, salt bridge. These three are the common terms. So see this one. So in this one, here copper, this rod, actually this is a one electrode, copper electrode, and this one is zinc electrode. These are the rods actually. So any by taking any rod, so zinc and copper, so the layers are applied here. So copper electrode, zinc electrode. This one, copper electrode, this is zinc electrode. And see this one, these are the electrode. Conduct electricity between cell and surroundings. So these are the electrodes. Next, what is the electrolyte? Mixture of ions involved in a chemical reaction to carrying the charge. That is called as electrolyte. See this one here. Here I am taking zinc. It is a electrode. If I take here zinc sulfate, okay, yeah, here zinc sulfate like that. If I take, this is a electrode. So this is zinc electrode. These are the electrolyte. If I take here zinc sulfate, that is a electrolyte. If I take copper sulfate here, this mixture, so this is called as copper electrolyte. So this is electrode, this is electrolyte. This solution is called as electrolytic solution, whatever here. Here zinc sulfate, if I take zinc sulfate, that is called as zinc sulfate electrolytic solution. This is copper sulfate electrolytic solution. And third one here, this one is salt bridge. Potassium nitrate, KNO3 is used as a salt bridge. Why we are using the salt bridge? Actually, the salt bridge is used to electrical neutrality. Whatever the copper sulfate electrolyte solution is here, and zinc sulfate electrolytic solution is present here. So between these two, whatever the two electrolytic solutions, so we are using salt bridge to electrical neutrality. This whatever the potassium nitrate, we are using opposite to U. Inversion like U type shape is here. So this is used for the electrical neutrality. What is the term used? Salt bridge. So this one, salt bridge is used to electrical neutrality, whatever in both the electrolytes. Yeah. So these are the common terms used in the electrochemical cell as well as electrolytic cell. See this one, electrochemical cell especially. Yeah. So in the electrochemical cell, what we have to take? Actually, we are taking two electrodes. See this one, two electrodes, zinc electrode, copper electrode, and electrolytic solution. This one, electrolytes. Yeah. See this one. So this is one electrode. I am taking it is as a anode. Okay. Yeah. Anode. This one. Left side is anode. Most of the times we have to take left side electrode is as anode and right side electrode is cathode. Okay. Yeah. Always. So at anode oxidation takes place. Anode to the anode anion will becomes and oxidation process will be takes place. So if I take here zinc, what is happening? Zinc lose two electrons. Zinc 2 plus 2 electrons will be so lose. That's 2 electrons will be going like this. Okay, if I take here copper, so zinc. If I take copper and silver, what is happening? Copper losing 2 electrons and forming copper 2 plus. In that Rm is copper silver Rm Ag plus. So Ag plus is gaining electron and forming Ag. So in this one, see this one. So this is oxidation half cell. This right side is cell is called as reduction half cell. What is process is happening in this? So see this. All these are similar type of the So similar type of this one. So in this left side electrode, what is happening? Anode. Uh, at anode, oxidation process is happening. So what is oxidation? Oxidation is nothing but increase in the oxidation state or lose of the electrons. If I take here copper, see this one, copper to copper 2 plus is conversion. That means here copper losing 2 electrons. That process is called as oxidation. So meanwhile, what is happening? Silver plus Ag plus is gaining 1 electron and forming the Ag. So this process is called as reduction. Okay, yeah, see this one cell diagram. At anode, what process is happening? At anode, oxidation happens. Copper to copper 2 plus is happens. Now, in this case, what is happening in at cathode? Ag plus A, 1 electron gives Ag. So this is reduction happens. Reduction happens. That's why this cell is called as reduction half cell. So in this, what is the happening? The process is oxidation. That's why this is called as oxidation half cell. So see this one. So in this case, anode anion. So oxidation takes place. So copper to copper 2 plus is coming. Whatever the 2 electron generated, so these are going like this here. So here electron symbol is here, here, so here. Then what is here? Reduction half cell. Reduction will be taking place here. Ag plus electrons gives Ag. So in this process, reduction is taking place. So see this one. Yeah. So in this, yeah, see this one. Yeah. So this is a oxidation of cell, reduction of cell. So this complete reaction is called as E cell reaction. So this left side is called as oxidation of cell. So these double lines, these two lines indicate the salt bridge. Okay. So here copper to copper 2 plus oxidation plus Ag plus 2 Ag reduction. So oxidation of cell left side one and reduction of cell right side one. This double line indicates the salt bridge. Yeah, next, cell potential. So what is cell potential? So tendency of an element when it is placed in contact with its own ion, either that electrode may be lose the electron or gain the electron. So by losing the electron, what will be happen? It will be converted into positively charged ion. By gaining the electron, what will be happen? It will be converted into negatively charged ion. So by losing the electron or by gaining the electron, what will be happen? If for example I am taking the magnesium and here I am taking one electrode. So magnesium sulfate solution is taking and magnesium some electrode is taking. So based on the nature of the electrode, either it may be undergoes the oxidation or reduction. For example, I am taking the magnesium sulfate solution and magnesium electrode. So magnesium nature is, so it has always lose the electron. So magnesium, by losing the electron, what will be formed? Magnesium to magnesium plus 2. That means here what is the process is undergoing? It is losing electron. That means magnesium undergoing the oxidation process. So oxidation process means it is losing 2 electron. Then what is the definition of the cell potential? When an electrode placed in an corresponding electrolytic solution, it either lose the electron or gains the electron. By losing or gaining the electron, what will be happen? Some potential will be developed in the electrolytic cell. Okay, here I am taking the zinc sulfate solution, some electrolytic, so some potential will be developed by keeping the magnesium electrode here. So what is the process is undergoing here? Oxidation process is going. So whatever the potential developed is called as oxidation potential. Okay, so that potential is called as oxidation potential. If I take the copper sulfate solution here and keeping the copper electrode in the copper sulfate solution, then what will be happen? Copper 2 plus will be what in the copper sulfate? So some ions are there. Okay, what are the ions? Copper plus 2 plus SO4 minus 2. Copper sulfate will be ionized into what will be happen? Copper 2 plus SO4 minus 2. In that copper sulfate, copper 2 plus ions are present. The 2 plus ions So we will gain the 2 electrons and forms the copper. That means at that process, what is happening? When copper rod or copper electrode dipped in the copper sulfate solution, so the process is undergoing reduction. Reduction process is undergoing. Copper 2 plus is converting into copper. Okay. Yeah. So copper 2 plus is undergoing to copper. Reduction process is undergoing. So this potential is developed. That potential is called as reduction potential. While copper electrode is dipped in the copper sulfate solution, some reduction potential will be developed. That is called as cell potential. Reduction potential of copper. So like this. So based on the nature of the electrode, it may be undergoes the oxidation or reduction. If the process is undergoes oxidation, the corresponding potential is called as oxidation potential. If the metal is metal or any element, whatever the metal undergoes the electrode undergoes the reduction process, so the developed potential is called as a reduction potential. Copper 2 plus 2 electrons is converting into copper, so that potential is called as reduction potential of copper. E of reduction, copper 2 plus oblique copper, some value will be developed, whatever the value equal to x. So E naught, E of magnesium to magnesium 2 plus gives some value will be developed y. So that is called as, so magnesium to magnesium 2 plus is called as oxidation of oxidation potential, and copper 2 plus 2 copper is called as reduction potential. So these two types of the potentials will be developed. But in generally electrochemistry, most of the times we will use the reduction of cell potential. Okay, reduction potential. We have two potentials are there. So first one, oxidation of oxidation potential and reduction potential. Yeah. So generally we will use the reduction half cell. We can convert it simply E reduction equal to minus E oxidation potential, or E oxidation equal to minus E reduction. That means by converting the sign of the value, we can convert it into corresponding. If I have E oxidation potential value, then I want to convert into the E reduction potential value. Whatever the value should be multiplied with the simple negative sign. Okay, then I will convert into corresponding whatever the oxidation potential or reduction potential. So E oxidation equal to E minus E reduction. So that is the conversion between the oxidation potential to reduction potential and reduction potential to oxidation potential. So yeah, calculating the cell potential. Yeah, what we are saying, we are discussing about the cell potential. Previously we discussed that, so magnesium, so keeping in the magnesium sulfate, it is undergoing the oxidation process, and copper sulfate in the copper electrode is dipping in the copper sulfate. What is it is undergoing? It is undergoing reduction. So how we have to know? By taking the two electrodes, okay, one is undergoing oxidation, one is undergoing reduction. But we want the some accurate values, standard values we want. Okay. So copper is there, zinc is there, silver is there, fluorine, chlorine, like this. All electrodes are there. They have the some fixed values, electrode potential values or fixed values are there. Okay. So what are the values we will see here? So calculating the cell potential value. See this one, calculate. The process of calculating the cell potential is simple, involves the calculation of, yeah. So to calculate the cell potential, what we have to take? One standard electrode potential. We have to take one standard electrode potential. So some standard electrodes we have to take. Calomel electrode, hydrogen electrode. First I am taking hydrogen electrode. We have already is there. We will discuss that one. Yeah. So we have hydrogen electrode. This one, the standard hydrogen electrode. So these all are the values corresponding. I will explain. So see this one. So this is the standard hydrogen electrode. So by using the standard hydrogen electrode, we can calculate the, so whatever the zinc, copper, fluorine, all these, whatever the table indicated this, we can calculate all the cell potentials. Okay. Yeah, we can calculate all this one. Now we are discussing about the cell potential. So E cell. So by using the hydrogen electrode, by taking standard hydrogen electrode, the E cell value of the standard hydrogen electrode equal to 0. So by using that one, we can calculate the corresponding cell potential values. Now see this one. So E cell value. If I take the E cathode as a standard reduction standard value, then some another value will be generated. That is, I can substitute here. So here 0 minus some x I am taking here. So E cell value how much? Minus x will become. So that is the value of, if I take here some electrode x, I am taking the electrode. If I take copper electrode, here copper sulfate, and it is attached to the, so it is connected to the hydrogen electrode. Now I am calculating the cell potential of copper electrode. So reduction potential of copper electrode, copper 2 plus 2, copper gives 0.34 volts will be generated. Okay, plus 0.34 volts will be generated. Here 0 minus 0.34 volts we have to, so we will obtain that copper value. If I take zinc, minus 0.76 volts will be generated by taking the one of the standard electrode, that is hydrogen electrode. Okay, by using like this we can calculate the standard values. Okay, whatever the cell potential value, we can calculate the all values, whatever this one. Yeah, see this one, fluorine, CO3 minus H2O to hydrogen peroxide flow, especially you know the fluorine, here chlorine, bromine, iodine. So these all are the halogens having the positive E naught value. So what is the process here? Fluorine is gaining 2 electron and forming the 2F minus. So what is happening? Reduction. So that's why these all are the standard reduction potentials. Okay. So fluorine gaining 2 electrons, 2F minus. So in all the electrode potentials, highest reduction potential value is fluorine. That's why it can act as a strong oxidizing agent. I will explain later. So see this one. So here 2H plus 2 electrons. So what is happening? 0. So that's why we can take it as a standard electrode. Okay, 0 volts. Yeah. So next this one. You see here chromium, aluminum, magnesium, lithium. So whatever the lithium, sodium, potassium, first A group elements comes under this one. That means negative E naught value, negative reduction potential values for the, what is that one? First A group elements, metals as well as zinc. Here zinc is important. Okay. Yeah. So this zinc having this one. So in this case, hydrogen is 0 value, and first A group elements especially having the negative E naught value, and in this lithium having the least E naught value, least reduction potential value for the lithium metal. That's why lithium can act as a strong reducing agent. That means it can convert other species to oxidation. That's why, so sorry, it can reduce the other species. Okay, yeah. So it can act as a strong reducing agent. Fluorine can act as a strong oxidizing agent. Why? Because it is having the highest E naught value, highest E naught E reduction potential value. So this one E oxidation potential, E reduction potential values. So these are what are the standard values. I will explain in the next class. So how it will be happen, I will explain. First of all, see. So what are the topics? So we will discuss today. So from first one, see this one. So definition of the electrochemistry. What is the definition? We have discussed interconversion between the electrical energy and chemical energy. So that one. And what are the cells? Okay. So two types of cells. What are the uses of the, first of all, electrochemistry? These two are the pictures indicates the uses. This one. And two types of cells are there. Okay. Electrolytic cell and interconversion between the electrical to chemical and chemical to electrical. That's why we have discussed this one. So electrochemical cell, chemical energy converting into electrical energy. In these two cases, that is happening. These two, and along with that, this one also. And this one, electrolytic cell. So by using the electricity, we are converting into chemical energy. This one, electrolytic cell. So this is a molten sodium chloride. Molten. Okay, yeah. So these two pictures. Yeah, this is the same. Voltaic cell is nothing but electrochemical cell. So this one, voltaic cell, electrochemical cell. In this, chemical energy is converting into electrical energy. So this bulb is on. So see this one, we are using already electricity. It is converting electricity into chemical energy. So this is called as electrolytic cell. So these two indicate these two one. And next, what is the scope of the electrochemistry? We have discussed in this. So what is the scope? What is the main uses of the electrochemistry? We can prepare or we can synthesize the metals like sodium and sodium hydroxide in. So we can prepare the sodium hydroxide, sodium metal, as well as chlorine, fluorine. So these chemicals can be prepared by using the electrochemistry. So this is one of the application scope of the subject. And second application, main application is, so whatever we are using daily life, batteries as well as fuel cells. So these are the applications of the electrochemistry only. Okay, whatever the batteries we are using, so these are because of the, so we have primary batteries, secondary batteries, all our fuel cells are there. So these all comes under the, so what is that one? This is also one of the application of the electrochemistry. And third one, what is the benefit of the electrochemistry? So by using the electrochemistry, less pollutant as well as less energy efficient. It is requires less energy to one chemical reaction. Okay, yeah. See this one. So this is a normal organic chemical reaction. So it requires what I already explained that. So solvents like that, high temperature is using. So compare with the synthetic chemistry, so electrochemistry is somewhat good. So better benefits are there. Yeah. So what are the objectives? We have discussed all these topics. So various types of cell EMF, nearest equation, and relationship between the delta G and K, equilibrium constant, cell potential, E cell. And also we have to discuss the conductance